Okay, we are to the last section of chapter or unit 1. We added and subtracted polynomials in the last section, and now we're going to multiply them. Okay, so first of all, let's talk about a monomial being multiplied by a polynomial. Remember, mono, that means one, so we have one term out front, and polynomial can be any number of terms. It could be one term up to a million, as many as you want. We're generally going to work with like 2 or 3 or 4 terms. So in our first example, we have a monomial, one term, multiplied by a binomial, 2 terms. And all it is distributive property. Looks just like distributive property we were doing in what, section 1.3? It's just now you're distributing something with a variable in it. Okay, so that's going to get multiplied by 3x, and it's going to get multiplied by negative 4. So 2x times 3x. If you think about how to multiply that, that means you have 2x times 3x. But what operation is really between the 2 and the x? It's just multiplication as well. We know that commutative property tells us the order does not matter in multiplication. So we can go ahead and choose to move the 3 next to the 2 and the x's next to one another. 2 times 3 is 6. And what is x times x? It's x squared. Okay, so before I was talking about how if you have, side note real quick, how if you have 3w squared plus 2w squared, that's like 3 wheels plus 2 wheels, that's going to give you 5 wheels. The w to the squared, w to the second power, w squared, it stays the same. It's just the coefficients that are changing. That's for adding. But when you multiply, totally separate side note there. When you multiply, you have to multiply the coefficients, the 2 and the 3, and get the 6. But you have to add the exponents on the variables. So we had x to the first power, x to the first power, add those together and get x to the second. Think about when you are multiplying to find area. Say I know that this is 4 feet and this is 2 feet. To find the area of a rectangle, I multiply the two sides and I would get 8 feet. 8 feet what? Squared. Okay, so you have to take those units and you have to make them squared because that's how we measure area. Same idea with a variable. You have to take those variables to the first power becomes to the second power. All right, so let me go back and finish this problem. Oops. Okay, that's nice and clean. So that was just 2x times 3x. We also need to do 2x times negative 4. Watch that sign. Well, again, we can choose to do a commutative property and move the negative 4 next to the 2, which would give me negative 8 and then the x behind it. Put all that together, 6x squared minus 8x. Okay, I don't expect you to do all this work every time, but that's what it is. That's the explanation of what we're doing. Second problem, you have this monomial, 2x to the third, multiplied by a trinomial. There are 3 things you need to distribute that to. 2x to the third times x squared. Well, 2 times that invisible 1 is just 2. And then for your exponents, when you multiply the x's, you have to add the exponents. So that would be a 5. Next one, plus 2 times 7 is 14. X to the third times x to the first. Add the exponents. It's x to the fourth. And then 2 times the negative 5 is going to be negative 10, and x to the third. You've only got x to the third, nothing back here, so it stays x to the third. Okay, binomial times a polynomial. So binomial means 2, and polynomial could be any number of things. In this case, we have a binomial times a binomial, and a binomial times a binomial there as well. You possibly have heard this one called FOIL before. We kind of stay away from that because FOIL is nice, but it only works in this particular problem when you have a binomial times a binomial. If you're working with monomials or trinomials or anything bigger, it doesn't work. So all we really need to think of this as, same as the last problem, it's distributive property. Okay, so first thing to distribute is 2x. That needs to go to everything in the other set of parentheses. So 2x times x is 2x squared. 2x times negative 4 is negative 8x. You also then need to distribute 3 to everything back here. So we get plus 3x, and then 3 times negative 4 is negative 12. Okay, sometimes we call this double distributive property because you're distributing twice, but the idea is that you're going to distribute everything in the first set of parentheses to everything in the second set of parentheses. And then generally, you're going to have some like terms to combine, and they usually are the middle ones, if you do it in the same order that I have chosen, which is the typical order. So 2x squared has no like terms, it just comes down. These two are like terms, so we are going to combine them. Negative 8 plus 3 is negative 5, and you just drop that x down with it. Remember, when you're adding and subtracting, you're not changing the exponents. It's when you're multiplying you are. Another side note, sometimes students will get confused and they'll say, I know when I'm adding and subtracting, I have to have like terms, which means you have to have the same exponents, and that is correct. But then they'll say, is that true for multiplying? And it is not. You can multiply anything you want. It does not matter if they're the same, because we know when we multiply, we add the exponents. Okay, so when you're multiplying, you can multiply anything, any exponents together. When you're adding, they have to be the same. Okay, same thing over here. Take 3y, multiply it times 2y. You get 6y squared. Take 3y and then multiply it by negative 3. That's negative 6y. Negative 1 is the next thing to distribute. Make sure you watch your signs. That negative 1 times 2y becomes negative 2y. And negative 1 times negative 3 is positive 3. Watch your signs. Look for like terms. Sure enough, we have some in the middle. So we have 6y squared minus 6 minus 2. That gives you a minus 8. And we leave the variable y and its exponent of 1. We leave that alone when we're adding. We do not change it. Another method to use for multiplication is multiplying using a table. Sometimes people call this the box method. First, let's just talk about how we would do it with distributive property. I tend to like distributive property. I always do it this way, but I will show you both. So if you're distributing 2x, you get 2x to the third plus 12x squared, 2x times 6x, and then 2x times negative 4 is negative 8x. Keep going. Ooh, nice pretty color there. Distributing a 1, that's the second thing in the first parenthesis, so that would just be plus x squared plus 6x and minus 4. And then you're going to look for like terms. This is the only one with an x to the third. X squared, I have 12x squared plus x squared. I remember that's a 1 coefficient. So 12 plus 1 is 13. Leave the x squared. Negative 8x and positive 6x, negative 2x. And then I have a constant right here of minus, hard to read that, but minus 4. So that's my answer. Now let me show you what that looks like using the table. Oops. Let me pull this down. Okay, move that so I had room. So I have 3 boxes along the top. I'm going to put the 3 terms from this trinomial up here. X squared, 6x, and negative 4. I could put a plus sign right here, but you know, we know if a number doesn't have a sign in front of it, we know it's positive. So you don't have to write the plus. It certainly wouldn't hurt if you chose to do that though. 2x plus 1. So we have a binomial that's going to come down right here. 2x and 1. And then what you're going to do is you're going to multiply whatever lines up with this. So x squared and 2x, 2x squared. 6x and 2x, multiply the outside terms on each one. That would be 12x squared. Outside of this box, I have negative 4 and 2x, negative 8x. Here I have 1 and x squared, 1 and 6x, and 1 and negative 4. And if you look, these are the exact same terms I have right here in that line. Then you would need to take one more step where you combine your like terms. Oh, what did I mess up right here? Did you guys catch that? 2x times x squared is 2x cubed. Watch out for that. I made a little mistake there. Make sure you fix it. This should be 2x cubed. Okay, so 2x cubed is all by itself. These two right here are like terms. Those combine to be 13x squared. And these combine, those are like terms, to be negative 2x. And then I still have my minus 4. That's it. Just a different way to multiply. Okay, so if you want to go straight to the box method on this one, you would need you would need a 2 by 3 box, so 2 rows, 3 columns, or you could go the other way. You could do 3 rows, 2 columns. Does not matter. I'm going to set up this way. Not as neat when it's hand-drawn, I guess. 3x squared, positive 5x, negative 2. And down here I have 2x squared and negative 1. I'm just pulling these straight from the polynomials. Then look at what's outside of each box, what's on top of it, and what's to the left, and that's what you will multiply. 3 times 2 is 6. X squared times x squared is x to the 4th. 5 times this 2 out here is a 10. I've got x times x squared, x to the 3rd. Keep filling them out. Negative 2 times 2x squared is negative 4x squared. Negative 1 gives me negative 3x squared. Negative 5x, and positive 2. Find like term. 6x to the 4th has none, so I write it. These two are like terms. That gives me a positive set. Oh, wait, those aren't like terms. I just fell into a habit, a pattern here, and that pattern wasn't really there. So watch out for that. I did my x to the 4th. This is the only x to the 3rd, plus 10x to the 3rd. However, I do have some x squareds that get grouped together, but they're this far apart. No big deal. That's nothing saying that they have to be right next to each other. Negative 4x squared minus 3x squared is negative 7x squared. Negative 5x is all by itself, and plus 2 is all by itself. And there you go. There's your answer. You are all set. Do not try to combine any of these that are left. They are not like terms. That whole long problem or expression is your answer. There are 5 terms in it. Okay, 2 little special examples. We have a perfect square. Why is it a perfect square? Because we're taking a quantity and we are squaring it, making it perfect. What students tend to want to do is they want to take this square and distribute it right here. So then you would get 3x squared. If you square that and then square the 5, you would get 9x squared minus 25. Sometimes students will say, no, you've got to put this negative sign in here, which would make it positive 25. Either way is wrong. Think about what a square really is. It means you have 2 of those, right? You have what's inside there times itself 2 times. Well, if you do it the way we've been doing with this distributive property, 3x times 3x is 9x squared. 3x times negative 5 is negative 15x. Negative 5 times 3x, negative 15x. And negative 5 times negative 5 is positive 25. These 2 terms in the middle are both negative. Negative 15 minus 15, and they're like terms. They don't cancel. They combine to give you negative 30x. Take a look at what we did in blue. That negative 30x is missing. That is why you cannot do it this way. You cannot take an exponent and distribute it when you have a polynomial. So you absolutely have to write it out twice like I just did and do the distributive property on it. Okay, that's a very, very common mistake that students make is they just distribute the exponent. You cannot do that. You need to write it out twice and then do distributive property. So you're distributing terms, not the exponent. And then one more special case, difference of squares. If you look at these two, you have the exact same things, just two different signs, one with a plus and one with a minus. So if you multiply that out, x times x is x squared. Then you've got a negative 5x, a positive 5x, and a negative 25. Your middle terms now, you have opposite signs, negative 5 and a positive 5. Those do cancel. So you are just left with x squared minus 25. Not super important that you know the names of these, but you definitely need to know how to do them. Perfect square again, write it out twice, multiply it all out. Difference of squares is something that's going to come up later, a couple units from now, that you will need to know the name of that, but not right now. You just need to be able to do distributive property on it. Okay, some for you to try. That first one I threw in a couple different variables. No big deal. Go ahead and try these. Pause it now and try these on your own. All right, check out your answers. First, compare your answers to mine. See if you got the same thing. If you did not get the same thing, see if you can figure out where you made your mistake. On the first one, I would remind you that you should, when you have more than one variable in a single term, you want to do alphabetical order. So when we multiplied 2a times 4b, the a should come before the b. Just the right technical way to do that. For the second one, make sure that you, when you multiply, you're adding the exponents. So 2 and 2 is 4. 2 and 1 became 3. That's again when you are multiplying the terms, you need to add the exponents. The third one, make sure you write it out twice. Do not distribute that exponent. We distribute terms, not exponents. Okay? All right, you're going to do a lot of practice on these. Make sure you can do them easily, and then you'll ace your mastery check. All right, bye now.